Hey everyone, welcome to the Latent Space podcast. This is Alessio, partner and CTO in residence at Decibel Partners, and I'm joined by my co-host Zwix, founder of Small AI.
Hey, and today we're together with Together. Welcome to the studio, guys.
Thank you. Thanks for having us.
Maybe you guys want to, I don't know how you typically give self-intros, but does anyone want to go first? Like how do we get our audience acquainted, especially to like who's speaking? Because it's unusual for us to do a 4-person pod.
Yeah, hi everyone, I'm Ce. Yeah, so I'm one of the co-founder of Together and the CTO working with the team on the technical things. Yeah.
I'm Vipul Ved Prakash, co-founder and CEO of Together.
I always consider you guys as one of the sort of all-in-one companies. I always want to say labs, but I feel like you're not a lab. What is the sort of origin of Together? And then what is it today? I feel like you used to be Together.xyz.
Right.
And then now you're Together.ai.
You know, I think fundamentally Together is about open and independent AI systems. We think this is, one of the most consequential technologies of our time. And when we started the company in June 2022, our focus was to build a platform for, open source, independent, user-owned AI systems. One way to think about it is big labs, frontier model labs, have built their own platforms for developer platforms for their models. We think of Together as a platform for everything else. Whether these are open models, whether these are models being built by companies that are owned by them. Our sort of XYZ roots, we have a fairly deep decentralization and open ethos that kind of reflects in all our platform and strategy and business. And we also, the way we structure our cloud is by combining data centers around the world instead of, we are today not located in hyperscalers. We have built a footprint of, AI supercomputers in this sort of a disaggregated, decentralized manner.
I know before Together you were at Apple, so you go from like the most walled garden, private,
right.
We don't say anything company to we want everything to be open and everybody to know somebody. What maybe did you learn from like the Apple way of being super close and polished, and maybe what are you taking now to Together to make it open, but also a very nice developer experience?
One sort of my background has been in open source for a long time. One of the first things I created was a collaborative spam filter. This is back in the day.
It's called Vipul's Razor.
It's called Vipul's Razor, and it became quite popular. And the first company I founded called CloudMark was built around, taking open source and building both an open side of it and a commercial product around it. I think Apple is, sort of very focused on providing this amazing experience to its customers with, most of the technology sort of hidden behind the product. And certainly the focus on fluidity and, applying complex technology to make everyday things simple is something that Apple does really well. And, that's been a sort of big part of how we think about our developer platforms. I think it informs it. The other thing is that during my years at Apple, we, worked a lot on deep learning. And one of the things that was sort of very viscerally accessible to me was how well these systems worked. We built an open domain Q&A system. This was based on Facebook's LSTM paper in 2016. And it was remarkable because we had a parallel system based on sort of information retrieval techniques, which is extremely complicated, didn't work that well. And, this thing we wrote in a week was just incredible performance. So I think some of those experiences, at least for me personally, sort of were creating this roadmap of how how important and powerful this technology is. And when the scaling laws paper was published, that was very clear. Like, it was in some ways something very profound. We've never had algorithms that improve in capabilities with scale out. So this is almost a new era of computing, and so that's been, I think, the influence of Apple. My years at Apple really, for me, like, crystallized the value of what we are doing at Together.
Mm-hmm. And how did you decide to join forces? Because you did a postdoc with Chris Ray at Stanford. We already had 3DAO from Together, and we talked about Hazy. What was like the meeting of the mind of, hey, I come from like the more technical postdoc, assistant professor background, and Vipul, you had a more product thing. What got you excited to like build this now? There's so many people.
Yeah, so I think, so we have been working on this together with Chris in the essentially last like 10 years, right? So it was like machine learning system 10 years ago was like power-based graphic model, right? And then convolutional neural network, and then all the foundation model that we see today. But if you look at this, I think that fundamentally, the thing we are actually optimizing is actually not that different. It's always about data movement across essentially all the stacks, right? So when you do distributed like computing, it's about communication across different machines. When you do, for example, flash attention, it's about data movement at a different essentially memory hierarchy, right? So we have been doing this in the last 10 years and seeing the field start grow. So we kind of feel the current kind of this like wave of technology is actually the perfect time to actually bring all the research essentially into something real. And we are super lucky that we got introduced to Vipul, right? So and then we hope to join forces and bring this to real world. Mm-hmm.
Yeah. It's very interesting that like it's an unusual team of like sort of research and industry. Like, you've been a third or fourth time founder now.
Third time founder, yeah.
Third time. And so like what is your first order of business when you like set up Together? Like how do you sort of put something like this together? Oh my God, I'm going to use this word so much.
I think I feel AI companies are really kind of driven by research, and it was actually like Chris and I had been talking about how to reduce the cost of building models. We felt that there aren't really big data moats around foundation models. They are built from a subset of the web. What is difficult is the cost of capital to build these, and one of the ways in which you can reduce this cost is by making more efficient systems. With that, it was really about finding the right set of co-founders and team. In fact, when Chris introduced me to Ce, and I think within the first 5 minutes of talking to Ce, I was like, "This, we are starting this company." And our early focus was thinking about this more sort of disparate set of resources, GPUs around the internet. Can we use those to build a model? And we really have to compress communication for when we do gradient averaging. There's just a lot of traffic, and if you can reduce that somehow, you sort of open up possibility of using cheaper compute, across the network. And Ce's research for a decade has been in that subject, and from there finding other folks in the network. I think there is generally a lot of excitement and philosophical alignment around what we are doing, which we publish papers, we publish open source libraries and code, we build open models. And I think a lot of people in academia in, machine learning and NLP, that's really what they want to do. So I think that's been really a kind of kernel for, composition of the company. And we are lucky to have, at this point, attracted some of the best researchers in the field. So I think that's the most important thing. And, the rest of it is sort of driven by a couple of these philosophies around independent systems and decentralization and, and good developer interfaces. You want to make it accessible. That's, just as important. And the rest follows from there, I think.
I want to try and fill in some of the blanks in the history of Together. I think people come on your website today and they say you raised $100 million Series A. They're like, wow, these guys are like super legit company. But it feels like RedPajama just came out a year ago. I remember we had Mike Conover in the studio who had built Dolly at Databricks. And you,
same day,
you announced it literally the morning we were recording. So we're like in the studio on our phones looking at it. And it's like, wow, this is like the first time now there's like a good curated data set to do open pre-training. So maybe let's start from there. Like, what was the motivation behind it? Why did you decide to do that? It's data sets are one of the things that most people don't want to work on. They just want to do models, not data sets.
Yeah. So first one is not the first, right? So I think it's actually built on a whole bunch of amazing effort the community already have. For example, Illustrator have the Pile, right? There's a whole bunch of amazing data sets have like C4, right, from Google, right? So I think really get inspired by the impact those like data sets have on the community, right? So I think when we did RedPajama, it was a time that people are really fascinated by Llama, the model, like Llama 1, right, which feel like decades ago, right? But it's kind of, people are really excited about the quality, right? So that's really like a big shift in people how to think about open model. People start to see hope, right? So, but the one problem of Llama is the data recipe is being described in a pretty detailed way in the paper, but the data is actually not there, right? So, and our original thinking is how about we take the recipe and we try to do our best effort reproduction and try to put it out such that we can learn from our mistake in the reproduction together, right? So that's essentially the original thinking behind RedPajama. We have been pretty happy and excited about what community are kind of build on it, right? For example, there's a data set called Slim Pajama, right, which do deduplication over our data
from
right?
Cerebras. Did they talk to you before?
Yeah. So we are very good friends, and we can discuss about technical perspective. We are pretty excited because I think it's kind of why we do RedPajama in the first place is that people can actually build not only models but also data sets essentially over that piece of artifact. Right?
Yeah.
So that's actually what inspired us to do the like first version of RedPajama data set.
Yeah. And then you released V2 maybe 2 months ago. 30 trillion tokens.
Yeah, 30 trillion tokens. So I think what's exciting about RedPajama V2 is not only the number of tokens, but we start to kind of learn from RedPajama V1. So one thing that we learned was like data quality is really the core, right? So you want to take this couple trillion token data set and try to bring them down maybe to 1 trillion or 2 trillion, right? The way that you are actually filter them, deduplicate them is not something that kind of pre-decided before you see the application, right? So you kind of want to have a modular framework to think about data quality, right? Given an application, let's automatically or maybe semi-automatically try to come up with a way to filter it down, right? So that's why in RedPajama V2, we kind of overlay the data set with like 40 different pre-computed quality signal,
yes,
right? If you want to reproduce your best effort like C4 filter, it's kind of like 20 lines of code, right? And then it's open up this opportunity you can actually put different filters together, learn the combination of filter. We are very excited to see what the community actually come up with using RedPajama V2.
It was retrospectively so obvious that this is a good idea that I wonder how come more data sets don't do this, which you just release the data set in with all these toggles that you can turn on and off.
Yeah.
Right? That you can sort of tune up and down the quality in ways that you believe is important to you. I just it makes so much sense now in retrospect because everyone just publishes their pipeline and then the end result. But what about all the intermediate stages?
Yeah, yeah. So I think there are multiple things there. So like first one, like I don't think we are the only one like doing that.
Oh yeah.
For example, like Doma from AI2, right? They have this very flexible format to actually put in those quality signals, right?
Oh, okay.
So think like we are actually coordinating with them, right? So you can actually load RedPajama using their tool. Right? Like the whole thing should work, right? So I think one fundamental thing that changed in the last year essentially, in the beginning, when people think about data, is always like a byproduct of the model, right? You release the model, you also release the data, right? The data side is there for you to essentially to show people, if you train on this data, you get a good model. But I think what start to change is when people start to build more and more those models, people start to realize like different subset of data set is kind of valuable for different applications, right? The data becomes something you want to play with, right? So I think we are kind of lucky that we happen to release RedPajama right at that point that we get this opportunity to actually learn from that.
Yeah. And you guys have a custom model training platform on Together too. You have a bunch of stuff in there for data selection, like a DSIR and things like that. How did you decide to work on that versus, because you first started with like some of the fine tunes on Llama. Do you see a lot of interest there? And I know you've been doing a lot of research on state space models and other transformer alternatives. Like, do you also see that as something you'll keep working on this year and push more people towards?
Yeah, I mean, we think of how to make training more efficient and building models more efficient. Part of that is being able to select the right data set. And this is why you have signals, DSIR. You can start with a small, a small data set and find similar documents, build models with that. So we think it's an important part of the kind of model build tooling that is sort of widely useful for people building different kinds of models. Similarly, we are running into the limits of how fast you can make transformers, and we want inference at 5,000 tokens per second, right? And I don't think we will get there with transformers, and we need we need to learn longer sequences. Data again becomes very, very expensive with transformers. So our work on space state models and all the research that we are doing there, and hopefully other labs will pick up on this and make it a kind of important target for optimization. But we think that open source is a great place for this. We can provide these recipes for data and for training to our customers who are building custom models themselves, and we are quite excited about the sort of progress we are seeing there.
Mm-hmm. Do you have some of these models available for inference on Together? Can people play around with a? Yeah, they're available for inference on our serverless platform. Cool.
Yeah, actually, so I always try to be the person who asks about acronyms in case people want to understand. DSIR, should we explain importance resampling, that kind of stuff?
Oh yeah, so DSIR is essentially the fundamental idea. So it's one of the paper from Percy, right? So essentially, if you know what you are doing, you can actually use that as a very strong signal about what data to put into the training process, right? So that's essentially the fundamental idea, right? So, and then more concretely, right? So there are actually different versions of like DSIR, right? So one version is like if you have the validation side, right? You can actually somehow measure the similarity between the validation side and also your pre-trained corpus, and essentially select the subset. And often there's actually like less targeted version of DSIR where you say, yeah, maybe Wikipedia is actually a very good corpus. Let's try to find more Wikipedia, right? You can think about that as one way to, you can think about it in two ways, either as a way to come up with different weights for different data slices, or or as a like filter type of step. Yeah, for your data set, I'll think about that as like data augmentation, right? So that's how we think about DSIR.
Got it. That makes sense. I will have to read the paper to understand a little bit more, because when you say things like we have to know in advance what we were trying to do with the model, then we do importance resampling, that is against the principle of general intelligence, right? Like the point is to train AGI.
Well, I mean, depends on, so depends on what do you mean by being general or generic, right? So I think you can always take a meta-learning perspective that we know the distribution of tasks that we care about, right? So you can always go kind of up in the ladder of how general the whole thing is, right? But also for many of the customers that we are actually talking to, right? They have kind of very targeted application, right? The benefit you can get out of that is you could build a better open model, often smaller, often easier to do inference if you know what you want, right? So I think the whole trade-off would be, and the x-axis would be how generic the whole thing will be. The y-axis would be not only the top accuracy, but also a whole bunch of the deployment cost, right? The size of the model, right? The robustness of the model. So I think different people will navigate the space in different way. And we want to be the platform, essentially, whatever point that you want, we have a solution for you.
One more thing on data before we go deeper on state space models. Are we running out of data? Is 30 trillion, can we go in order of magnitude? Can we go 5 orders of magnitude? What, how do both of you think about how much data we have and how much we need?
Yeah, so I think that's a very, very good question. So I think, I don't think we are running out of data on Earth, right? So think about it globally.
Training
right?
data,
So,
training class data.
Yeah. So I think, I mean, some of them are not accessible, right? But I do think there are many organizations in the world have enough data to actually train like very, very good models, right? So, I mean, they are not publicly available, right? But there are people who actually have access to those, right? So I think in general, right? So if you think about the data in the open space, right? So I guess that was specifically that you actually mean whether we are running out of data.
Yeah.
So I do think there need to be some way, right, that people who are training open models get connected with essentially data that's not internet data, right? So I think that channel need to be opened up for the open model to get more data, right? But I'm kind of on the optimistic side that the society will figure out a way that we can train open models just beyond this internet data. Yeah.
Beyond internet meaning books?
I mean, there are a lot of those, right? Books, right? Transcripts, right? Videos, audios, right? So the whole bunch of like data sources that we are not integrating into open like data set, right? So maybe they shouldn't be open, right? So I think the community need to figure out a way, like the best balance, such that we can have open models, but on the other hand, also have a reasonable collection of data that we can actually use.
I think a lot of people think that there's a theory that Whisper was released so that you could transcribe YouTube and then use that as a source of tokens. And then I talked to other researchers who are like, YouTube has very low quality tokens. Do you want your model to talk like a live streamer from YouTube? Because that's what they're going to do. So it's not clear, like what the quality of this data could be. I don't know. It's an interesting open question.
Yeah, I guess that depends on your application, right? Yeah. So I think as a platform, right? So our goal is whatever application that you have, so we have a platform that you can actually achieve your goal, right? So there are definitely applications that kind of make sense to speak like YouTube, right? Yeah. So, but there are probably also other applications that kind of more on the formal side, right? So I think there's going to be a diverse collection of models, both open and closed, right? So, and we kind of want to be the engine that powers that.
Yeah, for sure. I think it's just like there's a lot of people who own data sources who are doing the locally optimal thing, and humanity as a whole is losing out. So like New York Times is suing OpenAI. Stack Overflow shut down their API. Reddit shut down their API. X, made their own model, right, on Twitter data. We're just going to have all these like tiny little gardens of data that it would be useful in a general model, but everyone's just trying to make their own model, and it seems like globally suboptimal.
Yeah, I think you need to have some kind of a marketplace for figuring out how to get this data into models and have. I think we'll increasingly see more of that, and I think there's a positive aspect to it too. There is a incentive for creators to participate in a system which is sort of more fair relative to the capture of value by an AI company that's taking their data. But I agree. I think this is a big open problem that that needs to be solved, and I hope there will be serious efforts around it.
Yeah.
Let's talk about the most precious resource on planet Earth, GPUs. You have a lot of compute, obviously, but you also have a lot of product pieces. You have inference, you have fine-tuning, you have pre-training. What's the split in terms of usage? Do you see most people are just running inference on off-the-shelf models? Do you see maybe some last mile fine-tuning?
I would say right now, the top 5 models on our inference stack are probably all fine-tuned versions of open models. And
who fine-tuned them? You fine-tuned them?
Either they were fine-tuned by our customers.
By your customers.
Either on our platform or off our platform. And we are generally seeing that, that is the sort of trend where you can get better quality on your task by very sort of now easily adapting these models to your data. We also have over 20 big model builds happening on the platform, which are customer builds. So we see a lot of training, and it's also somewhat surprisingly a more continuous kind of workload. We had sort of imagined that this would be more episodic. You train a model and then you do inference, but what we find is, people train a model and then they train the next version and then the next version, which sort of grows in scale. So it's starting to, I would say training is still the bigger portion, but inference is, in some ways inference is super linear to model quality. And as the models are getting better, there's more and more inference.
Yeah. Oh, because they're more useful.
Yeah, they're more useful. Yeah.
So training is bigger. This is actually consistent with what we've heard from Mosaic, that people think that training is sort of like a one-time deal. You do one big run and then you're done.
Right.
It's never true.
Right.
I'm interested in like putting some numbers. I don't know what you have disclosed or what you want to disclose, but like how many GPUs do you have? Like, what is the equivalent amount of compute that you have? Because I understand that your GPU setup is different than what people typically think of like a giant data center somewhere, right?
I don't think we have shared this number publicly. It's so this will be the first time, I guess. Like we have close to 7,000 to 8,000 GPUs today. It's growing monthly.
Like what class of GPU?
They're mostly A100s and H100s.
Okay, got it.
And probably more, I think, split towards H100s now. And we are, we'll be sort of building this best of class hardware. So as there are other versions of these coming out later this year, we plan to have those in the fleet as well.
I know when we talked last year, you were also using some of the supercomputers by the Department of Energy. There was kind of like a lot of random GPU compute in the world. Have you seen that kind of getting timed down? I think maybe a year ago, people were like, oh, yeah, you can use this GPU computer that is going to be end of life. Has the bar changed to give access to those resources?
Yeah, so I think from our perspective, it's actually getting better. Yeah, so from the community perspective, because many of the institutions in the world, they are actually investing on hardware, right? So for example, we are working with one of the institute in Germany called Ce and AI, right, which gives us a lot of help on the compute side. So they start to have this very big GPU cluster, and they are actually sharing that with the community, right? They start to have, and it's not super big, right, but also not a small one, right? So you start to see this different labs that start to pop up, right, and because of the power of the community, they start to actually share that. So we actually find as a researcher today, it's probably easier for them to actually get a GPU than last year. Yeah.
Interesting. And then for you to buy them, what's the state of the market right now? Is it still extremely hard to get any? Do you have Jensen's phone number? Do you have a GM phone number? Or do you guys get the SDR because you're under 10,000?
NVIDIA is obviously motivated to help us both as an investor, and we are their customers. I would say the market is very tight still, and it's likely going to be this way for a while. As my sense, that the demand for AI computing has just kind of ramped up very, very quickly, and it will take a while for supply to catch up.
Can you describe how tight it is in, let's say, compared to like a year ago, 2 years ago? What do you mean when you say tight? Like, the things you want, you can't get?
You can't get them immediately.
Yeah.
They're sort of, minimally like 2 to 3 months out. Any inventory that shows up tends to clear very, very rapidly.
Yeah.
And we obviously sort of look at this in a very detailed and analytical way. There is 4 to 5 million GPUs that will be sold this year
per year,
from NVIDIA and others buying. And if you think about, 512 to 1,000 GPU cluster for a company, that's 4,000 to 8,000 companies, right? So it's in some ways a very small number. In other ways, this infrastructure, the cost of this infrastructure, the cost of the GPUs will be, $80 to $100 billion. And then you layer servers and data center space and electricity on top of that. That's, close to $250 billion worth of kind of compute, which when you compare to the cloud computing of today, AWS's last year was $88 billion in revenue. So this is a really kind of a build out happening of AI hyperscalers. It is much more disaggregated, and it's very, very global. So, we think that GPUs are going to be sort of a precious resource for a long time, and using them optimally is very valuable.
Yeah. Our friend Dylan Patel from Semi-Analysis, he wrote a post about the inference market recently, and obviously mentioned you guys. In his post, he said, our model indicates that Together is better off using 2 A100 80 gig system rather than a H100 based system. The temperature and performance testing also point to Together utilizing speculative decoding. Any thoughts? Is Dylan right?
What is this model, man? What does he know that they don't know?
Yeah, exactly. I wanna know. I guess like from the outside, and sometimes we even do it. We try and speculate on what people are actually doing. So for the first time, now we have a former guest writing about a current guest. So we want to know what you guys thought, and maybe what are some of the misconceptions that people from the outside have on what it takes to run like a GPU cloud today.
Big fan of Dylan's, by the way. I religiously read Semi-Analysis. I think there were some errors in that analysis. In particular, we were trying to decode it, and one of the things we noticed was that it assumed that input tokens weren't being priced. So I think that may have been an error in the model. I also don't think that there's this assumption that people are running this at a loss. I think it's very expensive. You can't do that for very long. And there are trade-offs in terms of, batch sizes you use and the kind of tokens per second performance that is, kind of system trade-offs. We've done a lot of work. This is one of the key areas of research for us. So our inference stack is a combination of 50 different sort of tricks and techniques, and we think there's a lot of room for optimization here. So, whichever hardware provides better performance, whether it's H100 or A100s or L40s, we can sort of measure price performance on particular hardware, and we tend to use that for that model, or in some cases certain certain customers have data streams which can be then optimized for a particular configuration regime. So we do fairly detailed work on how to make this more efficient, and so it's hard to from the outside just looking at memory bandwidth and estimating what's actually happening.
How much of these 50 tricks are you keeping to yourself, and how many are you going to open? Because we at TreeDAO obviously flash attention to is open source. He mentioned he loved to come work at Together because of how much you care about open source. How do you weigh that as a CEO and CTO?
I think a lot of it is open, right? Flash attention, flash decoding, etc. And we publish, something that's very really universally useful. It's going to produce better open source AI. We tend to, publish as open source. I think on the inference stack, there are open source inference stacks, which are pretty good. And it gives us, definitely today it gives us a competitive advantage to have the best one. And so we're not sort of rushing out to release everything about it. It's not overall that additive to open source out there, and it is particularly useful as a business for us to, provide best price performance. So we make these decisions. We have discussions. Anything that we keep closed, we generally talk about it quite a bit and decide like this is the piece that is closed for today, and it may not be the case. 6 months from now, it may not matter as much.
So I think being open is kind of very important, right? So I think the whole company actually built on this idea that open model going to be a there's going to be an ecosystem built around open models, right? So, and that's also how we are really lucky to attract this top group of talents to actually join us because of the dream and the mission that we have on our side to really facilitate the open ecosystem, right? So I think in general, it's I think all the ideas should be open, right? So that's why we publish papers, right? We actually talk about ideas, right? So I don't think it makes any sense to keep idea close, right? So there are some software artifacts that kind of really deeply embedded into our own stack. It's kind of only useful when you are trying to build a disaggregated cloud, right? So that part, right? So we are so that's maybe at some point that we're going to be open, as Vipul said, right? But at this moment, right? So we are kind of busy actually building it, right? So that's probably kind of getting to the picture about when that piece is going to be open, right? But I think on the research side, the ideas and for our people to publish things, I think that's really, really important, right? So I think that's how we get talent. That's how I think we as a company going to move the field forward.
And I noticed that you never used the word federated learning or inference. Is there a distinction that you draw?
So I mean, it's definitely not intentional, but I think federated learning have been used in so many different ways by so many different people. It starts to lose a very precise meaning about what that really means, right? If you go back to the original Google paper of federated learning, I think that's very different from what people are talking about today when they say federated. Yeah, we kind of want to be really precise about it.
And so your term is disaggregated.
So as an infrastructure, right? So that's disaggregated.
Right? Aren't most clouds disaggregated? What's different about?
So I think there are different ways. So one way is that most of the cloud are disaggregated, but some of that is actually being exposed to the user, right? If you go to AWS, you do know which region you are in, right? So I think one thing that we are trying to do is you have this disaggregated cloud, not only about location or geographically where they are, but about this reliability and also this diversity of this infrastructure, right? So, and we want to build a reliable, high quality layer over that user actually don't know, right? What actually happened underneath the cover, right? So I think that one of the difference that we are of the way that we are thinking about infrastructure.
Yeah, a bit closer to Cloudflare than AWS.
Yeah, the one way to look at it. Yeah.
We had one question here, which we'll just throw out. It's kind of fun. Going back to the sort of inference stack piece, maybe if you had to pull out like a call for researcher or just like point out interesting areas of work that you're interested in, what pieces of the stack have the most opportunity for improvement?
Yeah, so I think the way we are thinking about the inference stack is, so there are multiple things can happen, right? So you can do better algorithms like spectral decoding. You can change the model architecture. You can go really crazy on the system side, right? And you can also co-design the hardware, right? So it's not really clear innovation on single dimension will get you there. Yeah. So the key thesis on our side is if you only push on one direction, you are going to reach diminishing return really, really quickly. Yeah, there's only that much you can do on system side, only that much you can do on the algorithm side. I think the only big thing that's going to happen is when you ask all those dimensions to actually compound, right? So to have algorithm, model, and system all come together. So I think that's how we reach the next like 10 times improvement on inference, right? So I don't think there's a single dimension that is particularly important, but looking at this space in a joint way, right? Try to kind of co-optimize jointly multiple dimensions. I think that's going to be really important for the community to look at.
Yeah, we often see SE numbers from the team, and you have these multiple methods. Not all of them compound. So you mix these together, it's still similar results, and some combination of them will have this incredible effect that is really, really super interesting. So it's very systems, very kind of broad systems approach to it. That's the most effective.
I think I finally get the name of the company. Like,
bring it together.
Everything needs to be optimized together.
All right. Just quickly, how does all this work change? Just like some of the architectures change. I know with mixture of experts, like speculative decoding is a little less efficient because of memory bandwidth. How much of it do you invest when it's a maybe model-specific improvement versus more horizontal thing? Also, you're researching different architectures. So how much do you want to spend time optimizing what's state-of-the-art today versus what's coming next?
We do spend time on what's state-of-the-art today, as well as what's next. It's, the value we get from doing specific optimization, even for, what works well for a particular model on A100s with a particular bus, versus H100s, it's a worthwhile investment for us. So we will go down fairly deep into a specific architecture and specific hardware. It does also inform what works better where, and you don't have to take the same approach for every model and every sort of hardware setup. We can take these different approaches, and we do have these multiple systems now. We know that this, system B is better for Mixtral, and system C is going to be better for Stripetine or Mamba.
Before we move on from inference, we need to talk about Anyscale drama. So we're actually having Sumit on the podcast tomorrow, who also talked about kind of came to your guys' support
Defense.
about how important it's not just like, Together is saying this benchmark's not good because they look bad in it. How, I guess like it's a hard question to ask, but like, why did you decide to just come out and say it? And how maybe does that also reflect the values that you guys have about open source and openness and kind of like being transparent about what's real, and maybe hopes for standardizing some of these benchmarks to make it more clear?
Yeah. So I think first one is like, so it's a great service Anyscale is doing for the community, right? So I mean, it's very hard to do benchmark. The moment you do benchmark comparing n players, right? N-1 will be unhappy.
Yeah.
You have two tables, and maybe n of them will be unhappy, right?
Yeah. So
it's a very great thing that they're doing. And in some of the work that we are doing, we actually use RMOPerf, right? So it's a great thing that they're actually doing. So I think one thing that about benchmark is, and probably the professor part of me are talking, is a good benchmark should think about how it's going to incentivize the field to actually move forward, right? So if the benchmark really become a kind of standard, how are people going to over-optimize to the benchmark? Because people are going to do that. And when people are doing that, what are we actually trying to incentivize, right? Will that move the world to a better place? Or will that essentially have every single player focus on marketing or spending time or money on things that actually do not matter on the technical side, right? It's very hard to actually strike a balance, right? So I think the reason we kind of try to give feedback on the benchmark is kind of want to open up the discussion about how does the industry should come together and define maybe a common way that we compare with each other, right? So like how like database people doing TPC, right? Maybe you should have something actually similar, right? So we are trying to start some of the conversation. So it's not really like we jump out to say it's not good, because there's no way you can have a perfect benchmark, and that doesn't really exist, right? So just try to kickstart the conversation that maybe we should come together and do something that the community agree and align with the benefit the end user are going to get, right? So just get the conversation started.
Yeah, no, I've spoken to the Anyscale team after that, and I think they had really great intentions. And partly, I think it felt like it felt like very objective, but and everyone sort of had a reaction to it because it just didn't match their benchmarks that we've all run internally against different services. But I think a common industry benchmark run by an independent party versus one of the vendors,
is there one that you will point to?
I don't think one exists today. I think there should be. We're having some conversations about someone setting one up.
Yeah.
And there's lots of interesting aspects of this. Time to first token is a function of where the test was run from. There is different loads on these services at different times of the day and weekday or weekend. So you have to measure that well. And I think if all of that were done very well by an independent source, that would be a very useful service to customers and in the services themselves.
Yeah, I'll point people to artificialanalysis.ai, which is a new one that recently emerged. I don't know if they've done it right. It looks like a side project of a couple people. But I think it's in all the providers' interest to work with them and ensure that there's an independent third party that's measuring these things, right? Yeah, at least on the baseline. For me, what's worrying is more about what Toa was saying which is, do these benchmarks skew things in ways that customers might not be mindful of? Like, what are these things overemphasizing that we might be that we might be missing? And I don't really know. It seems like a lot of these services, a lot of infra services bundled together their version of quantization as well. So that means there's performance trade-offs. Like, you're not comparing apples to apples, the same model itself, even though it's like a llama variant or whatever. So what do people trade off? They trade off latency, they trade off price. Obviously, those are the first two. But what else, right? What factors matter in a inference business? It's an open question.
Yeah, so I think there's also the throughput, right? So there's the time to first token, right? So, and then there are things that users do not often see, for example, the reliability, right? The capacity, right? So that also have impact on user experience at a global scale. Maybe not a single query, right? But in aggregation, you can also see a whole bunch of like whether you are emphasizing P50, P95, right? So the whole bunch of things that you can actually play with. And of course, there's also quality, right? So there are different ways to actually make the whole thing faster, specification, quantization, or combination of those, right? So yeah, so there are so many things to actually play with. So that probably need a benchmark that the protocol is transparent to make sure like it's very clear what we are doing, and a whole bunch of check on the quality to make sure we are putting the right group of service in the same table. Right. So I think then essentially the user can actually navigate the space. Yeah. Right. So I think that's going to be good for everyone.
It's very important field, and I think hopefully there's a good third party that emerges from this. So I just want to touch on one more piece, which is I think I'm appreciating from this discussion that fine tuning is a bigger part of your business than I thought. the other big player in fine tuning is Mosaic. Well, Mosaic is more training, but like there's a bunch of other players in the fine tuning space. Like, what if I was a prospective fine tuning customer? What do I come to you with? Do I come to you with my custom data and that's it? Do I also have to write the fine tuning code? What level of engagement do you do with your customers?
I think across the spectrum. So there are, our customers are training models, pre-training models from scratch, and many of them will bring their data sets and use our infrastructure and training stack to train their models. There are others who have trained smaller models and want to scale up across infrastructure, scale up across data. So we'll sort of help them do that. We will have customers who are sort of initially started a little bit more consultative. They have a particular task and idea in mind, and we will help them get from there to the data set and the right model to achieve that task. So it's a spectrum, and our goal is we're trying to productize as much of this as possible so that the whole process can be fast and scalable. I would say there is a lot more understanding around fine-tuning now. Like even in the last 6 months, there are, open source tools, recipes, literature, podcasts, Discord channels where people are figuring out. And it really is, in many ways, one of the successes of open source is you have small collectives of engineers who are now creating the top models on open source leaderboards, and I have tried out all sorts of different sort of data recipes, creating synthetic data,
merging models.
So it's that's really fun to see, and I think that sort of agency that exists now is exciting, and that is we see a lot of that sort of being applied into products and more sort of commercial models that people are deploying in their applications.
And then just to, I guess, wrap up the Together, it's almost becoming like a platform as a service,
suite,
because then you release Together embeddings. How did you get 92.5 accuracy on 32K retrieval? And do you think we're kind of like getting to embeddings are just like we did everything that we could, we're getting to like the most optimized it's going to get, and then we should just focus on models and inference? Or do you think there's still room there to improve?
I don't think we haven't even got started on embedding. Yeah, so I think there are so many things. So like embedding is really fundamental for many things. For example, for RAG, right? So deepening application. So that's how people bring knowledge in. That's also the fundamental piece when you want to build a better model, right? So that's give you this understanding about what actually get into the model. You can actually use that to actually build a better data set, get a better model, then get a better embedding. You start this loop, right? Without the good embedding, the loop is now closed, right? So I think both on the quality side, how to embed more like dedicated semantics like into those vectors, right? How to deal with negation, for example, right? So, and how can you make the whole thing really, really fast, right? So I don't think we have like scratched the surface, even a little bit. So I think for the next couple years, we will see a whole bunch of new embeddings, maybe of different size and much, much faster than today. So I think it's a very active research area. I think people should invest more. Yeah.
I was surprised to see, I think Gina, there's Gina AI.
Yeah.
And then there's another guy, Teng Yu's Voyage.
Yeah.
They are coming out as startups purely focused on embeddings.
Yeah. So I think it's a very, very important piece of the system, right?
Yeah.
So you people haven't focused on a lot on them before, and they should definitely start to do that.
Yeah. Why are the Chinese universities so good at embeddings? you know what I mean, right? Like the BGE and...
Yeah. So actually, I don't know. Yeah, so I think embedding is something that I don't know. We just like released our first embedding model, so we still try to learn how to build embedding model. Yeah. So ask me again in 6 months. I'll probably have more insight about how to build a better one.
I just noticed that ADA 02 used to be at the top of the MTB chart, and then it's just like sliding down and down and down, and all the new models are coming out of China for some reason. Yeah. And I'm like, I don't know what's going on there. Okay, cool. So we cannot leave this discussion without talking about state space models. Well, first of all, how much of the company is dedicated to research? Like it's obviously like not production quality yet, but like,
it's like 45%. I was counting this morning.
That's huge.
Yeah. So that's
a big investment.
Yeah.
Okay. Well, I mean, it looks like it's paying off. So and then high level. I will confess or admit or mention for the listeners who are also similarly skeptical, I did not used to care about long context because I was like, 30K is enough, 100K is enough, right? I'm not, modeling DNA sequences or anything like that. Why do I need long context? First of all, I'll throw that open to you. But second of all, I think what Mamba did for me was change that perception of that it's only about a long context. Like the only reason you want sub-quadratic architectures is for long context. Actually, that's not true. It's also just more efficient to train, period. Right? So I'll just leave that open to you. Like what's the motivation that people should keep in their heads?
Yeah, so I think there are multiple things, right? So one thing is that, the moment your model can do for long context well, so it often means that it's kind of cheaper. Yeah, so that's why it can do long. In principle, transformer can do long context. It's just very expensive, right? So I think what those state space model is trying to do is try to push the size of the state, right? As small as possible. That's why it can do long context, right? And try to kind of decouple this quadratical dependency, right? To make sure you can have a much better execution pattern, right? So all of those, one direct consequence of those is you can do long context really cheaply, but on the other hand, also introduce a whole bunch of benefit even you are not doing long context, right? So I think that's actually probably equally important, right? Because state gets smaller, you can do really large batch size, right? You can actually be very faster, right? So and another thing is one of the hypotheses that we have is, for example, in Striped Hyena, it starts to have a hybrid architecture, right? It has part of it has state space model, and part of it is still the transformer, right? So different components probably deal with different things kind of better, right? So maybe by putting them together, by thinking about how information propagate, right, over this whole horizon of this context, you can probably get an even better quality model than transformer, right? So I think that's why we are kind of invest a lot of things, right, on those models, not only for the context, which is very important, but also for a whole bunch of benefits it could get. Yeah.
How should people treat the distinction between Mamba and Striped Hyena? What's the point of releasing these two as separate models? Is one sort of the Together proprietary one, and then the other is the more open research one?
Yeah, so I think it's pretty much a different stage of exploration.
Okay.
So they kind of have different hypotheses when we try to build those. Yeah, for example, there are different view about state space model.
Okay.
One is Hyena, another is Mamba, right? They're actually different architecture.
Different families.
Yeah. So when we build Striped Hyena, right? So the curiosity that we had is how good can we? So what is the highest quality non-transformer model we can ever build? Yeah. So the goal of Striped Hyena is try to see whether we can match Mistral. Yeah. And by fine-tuning it well, whether we can outperform that in some way, right? So it has a very, very strong baseline that we are trying to beat. So that's why this hybrid thing getting the picture, right? And for Mamba, it's kind of more, the curiosity was, so how far can we push for pure architecture, right? So then we start from this very systematic, from small to large, right? All the way to 3 billion, right? So the baseline was essentially the best 3 billion model. So I guess at different stage of exploration, at some point, I think they are going to converge. We actually learn different things, when building different models. I think they are just this intermediate stage in the exploration at different points. Yeah.
You mentioned the hybrid architecture. is that the model grafting that you mentioned in the Strapahina post, where I mentioned you can have transformers and not together? Like this is a concept that I hadn't heard before reading about this. So I think most people's mental model is like transformers or something else is not transformers and something else. How do you train a model that is hybrid? Is there any difference in like how you construct your data sets? Is there any difference in then how you run inference on it? How should people think about starting research in this field?
Yeah, so we were also very surprised. So when we come up with hybrid architecture, right? So the way to think about it is like you have different layers in the neural network, right? So like the state-based model for some layer will already give you the benefit. For the other layer, they could be transformers, right? They could give you this more global view of the sequence, but for other layer, don't have to have that, right? They can have all the other things that kick in, right? So we don't know what is the optimal mixture between different architectures. I mean, in principle, you can have Mamba, Hyena, and Transformer, and all those things that come together, right? And then you can see what makes sense. We have no idea what is the optimal way of doing that. So what we are excited about is now the community have a whole bunch of building blocks that they can actually like playing like a Lego, right? So just put together and see what happens, right? So we are kind of very excited about that. So we are in the process of trying to learn more like about this architecture. And when we know what we are talking about, we will definitely share with the community about how to do that in a systematic way. Yeah.
What are we still unsure about? Like, why don't we just, put all the money in the world in training these things now? Like, what is left to figure out before we scale this thing?
Yeah, so like if you look at how transformer like is being developed, right, in the last like 5 to 10 years, right? Yeah. So people don't start from like you have this attention, all you need a paper, and then let's put all the money in and then train that, right? You always start from this very systematic understanding about the scaling, about data quality, about essentially the limits, right? So I think for state-based model from the labs to the real world, you kind of need to go through the same process. But of course, the second time doing that is kind of easier, right? But I think there's no way you can get rid of this systematic step of studying scaling law, study what data to put in, right? So what's the impact of different data slices to the data to the final model quality?
Do you expect that the data inputs will be different than?
I don't know. So I mean but I wouldn't take that for granted that it should be the same, right? So that's one of the hypotheses that. So we have no opinion on that because I think that's the result of the study, not the assumption. Yeah, we do not need to assume that.
Okay, scaling laws and data. Anything else like architectural that we are not sure about? Because now you have this selection mechanism that you're pretty happy with.
I mean, first one, how to mix them, right? And second is, what is the architecture? So if you look at transformer, right? So one very interesting piece there is people optimize also the hardware to make sure that things run very fast, right? The very efficient kernel, the very efficient hardware, and then that's add another boost, right, for the transformer architecture, right? So I think that's something that should happen for state-based model. Which architecture is kind of easier kind of to run on the hardware, right? So whole thing going kind of faster, you can put more data, it add another dimension in the scaling law, right? So I think we just need to plow the whole space and just be really systematic from small model to 1 billion, 3 billion, 7 billion, just go all the way up, right? So I wouldn't jump around in the space. I would just like be patient and just like be systematic. I think we'll get there.
Yeah, well, looking forward for more research from you guys to figure that out. So one dimension which we didn't talk about, we talk about long context, we talk about efficiency, but speed is also very important. A good inference provider provides, let's say, 70 tokens per second, and then maybe that's faster than less good inference providers that are more like 30 tokens per second. But that's the rough range, right? State of the art today. That's around the human speaking speed. Human reading speed is about 200 words per minute. Words per minute. Yeah, it's words per minute. Anyway, so like, why do we need 5,000 tokens per second? Is my question back to Vipul. And maybe is this something that is an emphasis for research as well, or is this more just an inference only thing?
there are applications that are, consuming the tokens that are produced from end models. So they're not necessarily being read or heard by humans. So that's a place where we see that level of requirement today that really nobody can quite satisfy. There is, I think about how do you, as intelligence grows, how do you sort of increase the bandwidth of, how do you reduce the latency of it? If we can do 5,000 tokens a second, the same card can produce, the throughput of that card goes up significantly, and can support more applications. So I think it's important from that perspective. And then it opens up new UX possibilities. And once you can get sort of an immediate answer from a model, it starts working in a different way, and new types of applications will be created. We rarely run into users, except for perhaps those feeding this into a text-to-speech model, where they say that, okay, slower is better, or like we don't need more performance. So I think there is I think this may just be fundamentally very, very slow today in general, and we're just sort of used to that speed, and that will change once these models can get faster.
Yeah, 5,000 tokens per second is I don't even imagine. It makes me worried a bit that the machines will be communicating at a much higher bandwidth than us. But yeah,
I mean, they do that already.
They do that already.
Not in natural language.
They do that already.
Awesome. Anything we missed about Together as a product? We're gonna talk about the hackathon you just did and whatnot, but any last product thoughts?
I think one of the big sort of focuses of our product is to become more and more serverless. Like have AI run in AI development run in the serverless manner, and we are there now on inference, also on fine tuning. We are pushing to do that on training, and that is, we think, if there was a sort of developer experience message, that's probably the big one, is where you have enough flexibility. You don't have to sort of commit to thousands of dollars of compute before you can start using open models. We really want to change that and make it really as easy as possible to get started.
Yeah. When I first signed up for Together, I left an instance running, and I just ran out of my credits immediately.
Yeah. So and we changed that whole model now, so you never run into that issue. And that was and I think the response to that has been amazing. Is we also provide $25 free credits, which is a large number of tokens depending on the model you're using, and you really can build an app. You can do a fine tuning and run that model and build an app on Together for free, basically. And we'll be pushing further in that direction.
You just did a hackathon at AGI House about fine-tuning versus RAG for open source. Any learnings, recaps from it?
Yeah, so I think one thing that we kind of learn is so I think the hackathon was phrased as something versus something, right? But I think the combination of those works really well, right? It's so I think combining all those techniques all together, right? So we'll give you essentially another boost, right? So that kind of one thing that we learn on the technical side. Yeah. And also we are very kind of excited about the excitement of the audience, right? So I think people are really kind of using the platform and building something really cool. Yeah.
It's always surprising to us what people build.
Yeah. Is there something you're focused on this year? Hiring, building, engineering team? What should people that want to work at Together know?
All those things. I think hiring is a pretty big topic. We are 38 people in the team, and we are hiring across all the areas. If you're CUDA and Kernel Hacker, we have lots of exciting projects. If you're a researcher, you like to build models, we have exciting projects. If you work on systems and infrastructure and the cloud layer, we do a lot of work there. And as well as sort of front-end and developer experience and applications. So really kind of across the board, we have, I think, 20 plus postings on our job openings on our site. And folks who are passionate about open and, AI. I also say if you people looking at Together, they don't necessarily for all the postings have to have experience, professional experience working in machine learning or AI. Many of the systems people are sort of doing this for the first time, and they can apply their, systems expertise to the kind of things that we are doing, and we can teach people AI as long as they have expertise in other areas.
Will you call out what kind of expertise you're looking for? Like we definitely have systems people listening. So,
the whole stack, right? So like all the way from
Kubernetes. I don't know.
Kubernetes, yes. Yeah.
Okay.
CUDA.
What else? CUDA. Uh-huh.
Yeah. So and DevOps, right? So that's that's a big thing.
Is that like what Terraform, like Pulumi?
Right.
Yeah. Yeah. And all the way to machine learning systems, right? If you want to like to hack over like VRM, TGI, right? That's great.
Okay.
If you want to play with different fine tunes, right? Building models, like developing algorithms, right? Essentially the whole stack, all the way from application.
That's very broad.
to system, right?
Okay.
So I think that so a fun thing about the company is like we have this very diverse collection of expertise and talents in the company.
Yeah.
And the goal is really try to innovate at every single layer.
Okay.
And then have them all compound together. And yeah.
Doing everything together. That's why the company is named this way. Like, no, seriously, I didn't really get the company naming until now. Like, yeah, makes sense.
Awesome, guys. I know we kind of bent in the lightning round in the last few episodes, but I think for you two, one of the questions we used to ask is like, what's the most interesting unsolved question in AI? So maybe another way to think about it is, if you weren't building Together, what would you be working on?
Yeah, so you've not been Together. I'll be a professor. I mean, then we do all whole bunch of things without justify as being useful. We used to work on quantum machine learning for a while, right?
Wow.
So I think that's cool, right? So I think I'm very excited about. So I think IoT is going to become very interesting. So I know people have been saying that for the last couple of decades, right? But I think very excited about how does technology like Starlink, right? So like change the communication between different edge devices and like all those machines, and the new battery coming out, right? So I think that could be very cool. Yeah. So if you're not building Together, probably spend some time thinking about how to compress communication even more, given all the satellite communication stuff. Yeah.
I think sort of to the first question of what's one of the more important open questions. The one thing I think about is that we sort of need a framework of thinking about, what the world looks like with advanced intelligence systems in it. I think we have had this very, sort of a doomerism view of it, really kind of informed by science fiction, dystopian science fiction and Terminator. And I don't think we have a kind of a positive or a realistic, really, framework coming from, experts in the field. So I think that's a pretty important question, because that really gives us a roadmap of where this industry should go. And I'm hoping that some of the industry drama this last year maybe is sort of pointing us in that direction, and solving that is sort of, I think, important in kind of a in a meta way. I'm actually not sure what I'd be doing if I was not doing Together. So I think I'm doing the perfect thing. That's like this is really my dream job, and I have every day. This is kind of what I want to do, and I expect that's going to be the case for a very long time.
Awesome. Thank you guys for coming on. This was a lot of fun.
Thank you so much.
Awesome.
Yeah.